When I played Ocarina of Time as a kid, I always used to love getting the spiritual stones after completing the 3 child dungeons. The stones don't really have any gameplay purpose besides looking cool, but I was so impressed with the graphics at the time that it was enough to make them feel like an actual reward. Even today, there's still something about the way the low poly geometry reflects the light that gives them that distinct Ocarina of Time look. I decided that it'd be a fun project to see how closely I could match the look of the original N64 stones. So today I want to share with you everything that I learned so that you can make them too. It shouldn't come as a surprise that the N64 wasn't actually capable of rendering real-time reflections. Even modern game engines still struggle to pull this off. In order to create the illusion of reflective surfaces, the developers use something called reflection mapping, where a single texture is wrapped around the object to create the illusion of a shiny surface. By using this reflection mapping technique on some low poly geometry, we can create a convincing looking replica of the stone in Unity. This tutorial will have 3 parts. First, we'll create the geometry in Blender, then we'll create the textures for the reflection map using GIMP and Blender. Then we'll write the shaders in Unity that will allow us to use those reflection maps. As always, I'll provide the finished game object textures and shader code for those who want to skip those sections. Either way, I promise that by the end of this video, you'll end up with a convincing copy of the original green spiritual stone from Ocarina of Time. Alright, so the idea now is to use some reference images to make a 2D outline of the stone. And you can go ahead and download those from my GitHub. They're just from a stone that I'd already made in Blender. So let's go to Add, Image, Reference. Go to wherever you have the images stored and open the front. And then let's get the correct rotation by clicking N. And then 90 around X, and 0 and 0 for Y and Z. And then let's go ahead and move the image back. And then we're going to scale it to the correct size. And hold Control for this one. Should be about right there. And then now our problem is that the image is displaying a mirror on the other side, and we don't want that. So go to this Image tab, and then inside, hit Front. And then that'll remove the back face. And let's go ahead and do the exact same thing for the other 3 images. Alright, so now make sure you have the images arranged in a square like this, and then make sure that the back faces are removed for every single image. And now what we can do is add the plane and start working on the gold ring. So I'm going to go to Add Mesh, Plane, and then I'm going to rotate it around the x-axis 90 degrees. And I'm also going to remove the back face from this because when we import it to Unity, all the back faces will be removed. So let's grab the plane and scale it down. And then let's move it to about right here. And then rotate it. And now what we're going to do is try to match it up with all of the corners on the ring. So about right there. Let's see. Okay, that should be good. So now what we can do is go to Edit Mode and then grab the edges. And then whenever we want to move an edge around, what we can do is grab it and then press E to extrude. That'll make a new edge. And then R to rotate until the angle is right. And then S to scale. And then G to grab, and then move it into the correct spot, just like that. And then so now let's do it with this one. We're not going to extrude this one, so just grab it. And then we'll put it about right here. And it doesn't need to be perfect, but the better you do now and the better the finished product will look. So let's extrude again to about right here. I'm going to scale, move, scale, rotate, and then just keep making small changes until you have it right where you want it. And then once that edge is done, press E to extrude again. And we're just going to do this around the entire outside of the ring. All right, and that looks pretty good. So what we're gonna do is make this side of the ring now. So, oops, let's go ahead and grab this edge right here, and then E to extrude. And then we're just gonna use R to rotate, and then S to scale and do the exact same thing. So at this point, what we can do is notice that the back of the stone has roughly the same geometry as the front. So to save us some time, what we can do is with this ring selected, Shift D to duplicate, and then right click to put it right back where we found it. Let's go to wireframe mode. And then with this new plane selected, look down the x-axis, G to grab, and then move it until it's right on top of this ridge right here. And then once that's done, we can stop worrying about that plane. So let's go ahead and hit the I to hide it. Okay, so now at this point, let's think about what we want to do, because we know that this part of the ring kind of pops out a little bit and is in front of the emerald right there. So let's go back to edit mode and then tab select, or sorry, vertex select. And then what I'm going to do is grab these 6 vertices right here. And I'm holding shift to select multiple. And then what we can do is, I think if we look down the x-axis, we can press G to grab, hold control, and then just move them out like that until they're about right there. That looks good. And then now what we can do is grab some individual vertices and then just move them to the right spot. So I'm going to grab this one and I'm going to move it right here. And then let's see what else. If we look at actually, I think that should be good for now. So what we can do is you can see if I go to wireframe that there's this kind of ridge that goes along the ring. So let's try and add that right now. So what we can do is press Control R and then hover over the right spot until you have a loop cut that looks like this. Left click and then right click to put it right in the middle. And then with that loop cut selected, look down the x-axis, press G to grab, hold Control, and then move it out sideways until it's about right here. And then you'll notice that these ones look fine. These ones popped out too much. So let's go ahead and grab these and then move them back where they need to go. About right there. And that's looking pretty good. Let's see. Yeah, that looks pretty decent. Let's see. If we look at this one, you can see that he's kind of tucked in there, but I don't think he should be there. So let's grab and move to this corner right here. And then same for this one. Let's grab, move to that corner right there. And that looks pretty good. And with these ones, they're a bit too far back, so I'm going to grab them and then press Y to move along the Y-axis. And then just move it forward a tiny bit. And same thing with this, G, Y, move it forward a little bit. And let's see what we got. Yeah, I think that looks pretty good. All right, so now let's look at this ring on the left right here. So back to wireframe. If I grab this vertex right here and then look down the x-axis, oops, this vertex is supposed to correspond to this point right here. So let's grab and move him there. And then let's do the same thing with this one. So look down the x-axis, grab, move here. And then same thing with this one down here. Grab and move right there. All right, so I think that'll be it for the front plane. So let's actually hide the front plane and then look at the back plane. So I'm going to go to object mode and then hide this one and unhide this one. And then we actually want these faces to be facing the other direction. So let's select him, tab to go to edit mode, press A to select everything, and then mesh, normals, and then flip. So now everything is facing this direction. And then let's also go to wireframe And you can see that we have a bunch of vertices that are either in the wrong spot or that we don't need. So what I'm going to do is highlight these ones and then shift to select multiple. And then with all these selected, I'm going to press delete and then vertices. And then you can see that there's no closing edge right here. So select these two, F to fill, and then shift select this third one, F to fill again, and now there's a face right there. So now let's move some vertices around. So grab him, move right there, and there, and there, and right there. And these aren't going to be perfect. That's going to be fine. Just move them as best you can. Right there, right there, and right there. Okay, so I think this angle looks pretty good. Let's see what it looks like from the x-axis. So you can see that we have everything in this sort of plane right here, but they need to be either shifted to the right or the left. So let's do that right now. So what we can do also is these two right here that I said don't worry about, we can select both of them, press M to merge, and then hit at center. So now these two vertices are just one vertex. And then let's put them right there. And if we look at this guy right here, down the x-axis, you can see that he probably needs to be right here. So let's grab and move right there. And then this guy up here needs to be moved to the right, like that. And then if I look at this one and this one, I'm actually going to select all three of these right here. Look down the x-axis, grab, and then move him over a bit. And let's actually grab him, move him right there. And let's see. I think that's starting to look pretty good. Let's look at these vertices right now. So how about this one? Yep, that one's way too far to the right. So let's grab him, move him there. And then this one in the bottom left is also too far over. So let's move him. And then now it looks like all of these vertices down here are a little bit too far to the left. So if we look down this axis, let's grab, shift Y, then move them there. And let's see. Yeah, I think this one needs to be moved over as well. And what about this one? Yep, that one needs to be moved over. So G, Y, move them over right there. And then I think this one also. So G, Y, and right there. So let's see what we got. Yeah, that's looking pretty good. I think that's all we need to do. So let's go ahead and unhide the original plane. And now you can see that we've got pretty much a 3D shape going on. I'm going to switch to object mode. And it looks like that's pretty much what we want for the gold ring. So now I think we can go ahead and join these objects. So I'm going to hit this one, shift to select this one too. And then what we can do is object join. So now these are the same object. And if I go to edit mode with tab, you can see that we probably have some vertices overlapping. Like if I grab this, you can see there's still a vertex right there. I think there's one on this side. Yeah, these two are separated. So what we can do is hit A to select every single vertex, M to merge, and then by distance. So with this, we can set a cutoff where if it's below this distance, it'll merge, and if it's above, it won't. So I think 0.01 meters is a pretty good cutoff. Let's try it. I'm going to hit enter, and you can see that we got some of them, but not all of them. So let's try 0.04. Maybe not. I'll try that again. Maybe 0.05. And yeah, that's still not good enough. Maybe, let's see what happens if we do 0.1. Yeah, still nothing. Okay, let's try and do this manually then. So what we'll do is go to wireframe mode, select all these, merge at center, and then that looks pretty good. And then how about these? These are connected. Let's see, we can grab these ones, merge at center. And then what else we got? I think these should be good. These are good. These ones are obviously not good, so I'm going to select them, merge at center, make sure it still looks okay. And then what else? Yeah, these ones right here. So merge at center. And then I think that looks pretty good. So let's go back to solid shading. And yep, so it looks like we've merged the two planes successfully. All right, so at this point, all that's left is to fill in these empty faces right here. And the correct way to do this would be to hold Alt-R and then, let's see, select this loop cut. And then what you would do is press F to fill. But you can see if we do that, it creates this really weird geometry for some reason. So unfortunately, what we're going to do is actually fill in all of these faces on our own. So for example, this one right here, I'm going to shift to select all these vertices and then just press F to fill, and that'll make the face for us. So we're going to do that along the whole edge of the ring. All right, so just looking at the object, it seems like the gold ring part is done. So now what we want to do is add the green emerald that sits in the middle. So what I'm going to do is, while in object mode, add mesh circle. And then we're going to have 8 vertices, and the radius is going to be 0.25 meters. And then I'm going to rotate 90 degrees around the x-axis. And then if we select our circle tab to go into edit mode, I'm going to press F to fill in a face. And then let's go to wireframe mode. And then I'm going to go ahead and hide this plane actually. So it looks like the size we want. So what we can do is press I to inset a face and then just match it up with the image behind it. And then what we can do is, with that face selected, look down the x-axis, grab, hold Control, and then move it out to about right here. And then looking back at the face, we can right click and then press, with face select, right click and then poke faces. And that's going to create a little vertex in the middle. So let's go ahead and grab that. Look down the x-axis again, press G to grab, and then move it right there. Okay, so back to object mode, solid shading. That looks like what we want. So what we can do is go to the modifiers tab, add modifier, and mirror. And let's go ahead and press Control A, location, rotation, scale, and then let's mirror down the y-axis. That looks pretty good. So I'm going to go ahead and apply that modifier. And let's bring the plane back now. So next, we want to combine these two objects together to make it easier when we import to Unity. But first, let's add a material to each one, because in Unity, these should each have a separate material. So I'm going to select the emerald, go to the Materials tab, New, and then I'll just call this green. And then on the base color, I'll just set it to green, like that. And then now let's select the gold ring, New, Gold. And then let's try to make this one slightly gold looking. Okay. And then if we go to Material Preview, you should have something that looks like this. And then now let's select both objects. And then go to Object, Join, like that. And then now let's go ahead and hide all these images. We shouldn't need those anymore. And if I go to Edit Mode and then Wireframe, you can see that we have the same problem that we had before, where we have these sort of duplicate vertices, right? So let's see, what can we do to fix that? Let's hit A to select everything. And then I'm going to merge by distance again. And obviously you can see that 0.1 meters is, oops. Let's go back. Merge at distance. 0.1 meters is too large of a distance. Let's try 0.01. And that looks pretty good. If I go to wireframe, it looks like pretty much every vertex that we wanted to join has been joined. Let's see. Yeah, I think that looks pretty good. So now what we can do is kind of adjust some individual vertices that are in the wrong position, like this guy, for example. If you can't select him, then go ahead and go to wireframe. And then let's look down this axis, and then let's just move him to the right spot. This part, again, doesn't need to be perfect. The emerald is going to be transparent, so even if it's off, it'll be pretty hard to notice. So let's grab him. Move right there, grab him, move right there. Let's see, this guy looks pretty bad too. Right there. Let's see, anything else? Yeah, these guys right here look pretty bad, so let's grab him, press G and then Y to move along the Y-axis. And then move it until it's about flush with the emerald. And then let's go ahead and grab this guy way back here. GY. And then I think he wants to be on that corner right there. So let's G, move there, GY, move back about right there. And then let's see, this one is also too far back. So GY, let's see. Yeah, where does he want to be? I moved it the wrong way. All right, there we go. And then let's go ahead. Put him about right there. And let's see. Yeah, I think that'll be pretty good. All right, so the model itself is done. And what we're going to do is first, let's go to object mode and then Control A, location, rotation, and scale. And next, what we're going to do is actually shade the object smooth, which is going to change the way it reflects the light. So to do that, we'll go to Object and Shade Smooth. And you can see that the edges don't look as sharp anymore. And if we go to the material preview, you can see that it's kind of reflecting in the way that it would on the N64. All right, and now with that done, what we can do is export this to a Unity project. So go ahead and create a new one and then find out where the assets folder is located. And that's where we'll be exporting to. So with the object selected, File, Export, FBX. And then I'm going to limit to selected objects and apply transform. And then export the FBX to your project. Now that we have our object, let's get back to that idea of reflection mapping. The principle behind reflection mapping is that for every point on our object, we can imagine a ray of light coming from the camera, bouncing off that point, and scattering into the distance somewhere. In other words, we'll trace the path that each ray of light entering the camera would take, but in reverse. Now let's imagine we have a big box around our scene. A box that's so big and so far away that it's like the sky. A skybox, if you will. It's clear that if we follow the path of each ray of light coming off of the object, it would strike some specific point on the skybox. For flat objects, the rays of light would all be very consistent and aligned. And for rounder objects, the rays would bounce all over the place and hit a bunch of different scattered points. Let's put different colors on the different sides of the box, and we'll make a shader that turns the object into whatever color the ray of light hits on the box. If the ray hits the red side, that part of the object turns red. If the ray hits the blue side, that part turns blue. This is the essence of reflection mapping. Find out where a reflected ray of light would hit the skybox, and that tells you what color the surface of the object would be if it were reflective. To make things even more realistic, we can add more detail to the texture on the skybox and find out not just which side was hit, but also at which point the collision occurred. Match the coordinate of the ray collision to the coordinate of the texture, and suddenly this reflection is looking a lot more detailed. A few things we should know at this point. This can't just be any random texture, or the results of the reflection would look terrible. We have to specially design these textures to be stretched over the faces of a cube without getting distorted. These kinds of textures are known as cube maps. This is also a very specific type of reflection which is static rather than dynamic. In other words, it won't capture reflections from everything in your scene, especially if those things are moving. You've also probably noticed that this sounds a lot like a reflection probe in Unity. And that's because this is exactly how a reflection probe works. The probe is like a 3D camera which takes a snapshot of the surrounding scene and puts it into a cube map texture. Then any objects around the probe, which are shiny, will automatically start using that texture as their reflection map. The fact that reflection probes work this way is actually pretty useful for us. As far as I know, there's no free software that will take a 2D texture and then give you the corresponding cube map. So what we're going to do is draw a texture, overlay it on a sphere in Blender, and take 6 screenshots, one for each side of the cube map. Then we'll put those screenshots into a Unity skybox, capture the skybox into a cube map texture with the reflection probe, and then use that as a reflection map. It's a lot of work, but that's the price of perfection. You might wonder why we can't just use the skybox as a reflection since it's technically a cube map. The problem with that is you can only have one skybox at a time, and the textures that we'll be using to mimic N64 reflections probably aren't what you imagine your game's skybox looking like. Alright, so we're back in Blender now, and we're first going to make the gold reflection map. And as a reminder, the idea here is to create a sphere, draw the texture and overlay it on the sphere, and then take some pictures with Blender's camera, and then put those pictures into the skybox. And doing it this way will naturally account for the fact that the texture is going to be stretched out when it's put into the skybox. So let's go ahead and add mesh UV sphere, and we're going to keep the default values, that's fine. And let's go on over to texture paint with the sphere selected. And you can see that our sphere is this ugly pink color. So the reason for that is there's no material. So let's go to the material properties tab, create a new one, and we'll call it gold. And we don't want this texture to interact with light and shadow. So let's change the surface to emission. And then in the texture paint window, we can go ahead and create a new texture, and we'll call it gold texture. And we'll make it 256 by 256. Okay, it looks good. And then over here in this yellow color button, go to image texture. And then in this tab, select the texture we just made. And you can see our sphere turns black. And then if I paint on this texture, it shows up on the sphere. So I'm going to Control Z to get rid of that. And to actually make the gold texture, it's pretty difficult to get it accurate if we don't have the original texture that was used in the game. But what we can do is, it looks to me like it's sort of gradient with some different gold hues. So I'm gonna try to make it look as best we can based on the reflection in the game. So to do that, what we can do is click on this fill tool right here, and then go over to this tool settings tab right here, and then we can change the way that the fill will work. So go over here to gradient, and then what we're going to do is add 6 tabs, and then we're going to spread them out kind of evenly. It doesn't need to be perfect, they can be kind of random looking. And then for this one on the left, the color we're going to use is just kind of a standard looking gold color, so kind of in between yellow and orange down here. And then this one at the far right needs to be the exact same, so I'm going to use the eyedropper and then click it right in the middle, and then it should be the same. And then we can see what this looks like by coming over here and just dragging it straight across the texture. So you have this gold and then black to white and then back to gold right here. So for the second tab, I'm going to change the color to a more dark gold looking color. So I'm going to decrease the saturation and then have it maybe somewhere around here, kind of close to kind of orange brown. And then I'm going to try and drag this one away a little bit. And then right here, I'm going to go back to that original gold color. Maybe scoot it a bit closer. And then right here, let's do kind of bright white kind of gold. So maybe up here. Looks pretty good. And then right here, we're going to go back to that dark brown. Oops. Like that. And let's see what that looks like. Yeah, I think that looks pretty good. Maybe a little bit brighter right here. So go closer to white. And then drag it across again. Yeah, that looks pretty good. So you can imagine as the gold ring rotates, it's gonna kind of rotate across this texture. So it's gonna go from gold to dark to white back to gold. So that looks pretty good. And then if we look at our sphere, we have a bit of a problem here because the texture kind of gets pinched at the top right here. And the reason that's happening is because if you look at the UVs, all of these triangles are sampling different colors, but when they're overlaid on the sphere, they all kind of end up at the exact same point. So you get this point that has all of the colors basically in one spot. So to fix that, what we can do is go to UV editing, hit A to select everything, and then R to rotate, hold control, and then just rotate it 90 degrees. And if we go back to texture paint, we can see that we have these loops and there's no kind of pinched corners anywhere. The problem is now that we want these loops to be vertical, not horizontal. So let's go to layout, and then with the sphere selected, look down the x-axis, R to rotate, and then just rotate it 90 degrees. And let's look at the material preview. And there we go, that looks pretty good. So let's see, what are we gonna do now? Let's go ahead and make the camera. So I'm gonna go to the wireframe selection. Oh, we have one more step actually. So let's go to the solid shading. And then if we took pictures of the sphere right now, the image is actually only displaying on one side. So we wouldn't see the image correctly. So what I'm going to do is go to edit mode. With everything selected, I'm going to go to mesh, normals, and then flip. So the texture is actually going to be displayed on the inside of the sphere now. So let's go back to wireframe and then back to object mode. And then we're going to add a camera right there. And then I'm going to go ahead and zero out the rotation. So it looks like that. And then get to this tab by pressing in with the camera selected. Okay, so let's look at the camera properties because right now the camera is a bit stretched out and we need the picture that it takes to be square. So to fix that, we're going to go to the lens unit. We're going to change that to field of view and we're going to go to 90 degrees. And this is going to make it so that the image that the camera takes matches up perfectly with the skybox. And then we're going to go to the output tab, and this is for the output of whatever picture the camera takes, and just change the resolution to 128 by 128. And that's going to make the picture a smaller resolution, and it's also going to be square, which is what we want. All right, so I believe the camera is ready to go and our texture is ready to go. So make sure again that you know where the folder for your Unity project is, and we're going to be saving to the assets folder, okay? So to actually take the picture, I'm going to hit F12, and then you can see that this little image pops up. And go ahead and save this image wherever your folder is, okay? And then I'm going to save it as, here, let's see if I can find out where it is. Okay, yeah, this is my SS folder. So what I'm going to do is actually save it as down because the camera is looking straight down, okay? So that one's good. And then hit N to go to the camera transform. And then we're going to rotate 180 degrees around the x-axis. And that's going to make the camera look straight up, right? So I'm going to hit F12 again to take a render. And then we get this image. And I'm going to save as, in the same folder, I'm going to save as up. Okay. So now let's put X at 90 degrees. And now it's looking kind of horizontally. And F12. And I'm going to save this image as, this is actually going to be positive Z. And I know the camera is pointing in the positive Y direction, but Blender and Unity use different axes. So let me get that again. I'm going to save it as positive Z, because that's the direction it'll point in Unity. Okay. And then let's rotate around Z by 90 degrees. And it's pointing in negative X, so we can go ahead and save this as negative X. Negative X. And then Z is going to be 180. And now it's pointing in the negative Z direction. So F12, image, save as negative Z. And finally, we're going to do Z 270. And it's pointing in the positive X direction. So F12, image, save as. And what did I say? Positive X? Yeah. So we're going to save this one as positive X. All right, so that is everything we need to do for the gold texture. All right, so we're in GIMP now, and we're only going to be here for a few minutes just to create a noise texture. So what I'm going to do is go to File and New. Hello, it is me from the future, and this will actually look a lot better if you make this texture with 128 by 128. At the end of the video, I'm going to switch to that kind of texture, and it looks a lot better. So I would recommend playing with that, or even 64 by 64 if you want to get a more accurate N64 texture. So I'm going to keep using the 256 from this point on in the video, but just remember I would do 128 at this point. And then just create a new 256 by 256 texture. And it should look like this, and then we can go to Filters, and Noise, RGB Noise, and then just get rid of the red and the blue, and then crank the green to 100%. And then I'm going to unselect linear RGB so that we have something that looks like this. And that looks pretty good, so I'm just going to hit OK. And that's really all we need to do. So go ahead and go to File, and then Export As, and then save it somewhere you can find it easily as a .png file. All right, so we're back in Blender, and we're going to do the same thing we did with the gold texture, but now for the emerald texture. So let's go ahead and delete whatever material we were using before. And then I just made a new material called green. It's going to use emission shading, and then it's going to use an image texture again. So let's click on the sphere and then go to Texture Paint. And let's go ahead and open, I don't know what this is. Let's go ahead and open wherever you save that green noise texture. Let's see. So here it is. And you should have something looking like this. And then go to the Material Properties tab. And then for the image, just select the green noise. And you should have something looking like this. And yeah, it's going to be pinched on the sides. And that's because there's no way to kind of have these little triangle tips sample the same thing, but that's okay. I actually want the sphere, I want these pinch points to be on the top of the sphere again, so I'm going to go to Layout, and then I'm going to rotate the sphere back to where it was originally. like that. So back in texture paint. Now you should have something looking like this. And I kind of want to, if you look at the N64 stone, there's these kind of like, I don't know what you would call it, these kind of like white spots where it's reflecting the light very strongly. So I want to go ahead and add that to ours. So let's go to this brush, and then we're just going to leave it on the white color, and then go to stroke, space, and then I think all of this should be okay. And then let's decrease the circle to about right there. And then I'm just going to add some random white spots. It's a bit too strong, so I'm actually going to dial the strength down to about 50%. So maybe like that. And then just add these little spots all over the place. All right, that looks pretty good. And then I'm also going to make it so that these green pixels kind of stand out too much and they're a bit too distinct. So what we can do is actually go to this tab and then go to, let's see. I'm sorry, not that tab. We're going to go to the soften tool right here. We're going to press F to increase our brush to this size. And then with the strength at 100%, we're going to click once and then, oops, Control Z. We want the fall off to be this one, because if the fall off is like this, the strength of the soften is going to decrease as we get closer to the edge of the brush. So with this one, the strength is consistent. So click once and then twice, and then you should have something looking like this, and that's what we want. So now what we're going to do is go back to layout, and then let's click on the camera, and then press N to get the transform. We're going to go back to 0, 0, 0. And then we're going to do the exact same thing that we did for the gold texture. So you're going to want to create a new folder in your Unity assets, and then you're going to save these textures to that folder. And you want to do that because they're going to have the same name as the gold textures that we just created. So go ahead and make that new folder in your Unity project. And then we're going to hit F12. And then we're going to do image, save as, and then go to wherever you have your folder. And then I made this folder called Emerald Textures, and we're going to save this as down.png. And this is in the Unity project. And then rotate X to 180, F12, image, save as. This is going to be up. And then X is 90. Remember, this is looking the positive Y direction, but in Unity that will be positive Z. So F12, image, save as. This is going to be positive Z. And then we're going to rotate 90 degrees around Z. And then this is looking down the negative X direction. So F12, image, save as, negative X. Don't know why I capitalized that. Negative X. And then let's see. 180 around Z. And then this is going to be in the negative Z direction. So F12, image, save as, negative Z. All right, and then one more, Z 270, F12, and this is going to be positive X. All right, so that should be everything we need to do in GIMP and Blender. All right, so we're back in Unity, and here is a sample scene that I've set up. So here's those gold textures that we took in Blender, and I'm going to select them all by holding Control. And let's change some of these import settings to get them ready. So I want them to be high quality compression. I want them to be 128 resolution. And the filter mode, I'm going to do point no filter. And then wrap node mode, I've noticed that if you have anything other than clamp, that it doesn't get set to the skybox properly. So I'm going to set that to clamp. And then let's apply. And that'll apply to all 6 textures. So now we want to put these in the actual skybox. So to do that, we're going to create a new material. And we can't just use any old material. So let's click on the material and change the shader to a skybox shader, and it's going to be 6-sided, and that's going to let us put all 6 of these images in. And to find this, let's rename it gold skybox. All right. And let's go ahead and put down in the down slot, -x in the -x slot, and -z, -z, +x goes to +x, +z, and up. All right, there we go. So we have the skybox ready. Nothing has changed yet, and that's because we need to go to lighting and environment, and then let's drag our new skybox into the skybox material. And there we go. So it's almost like we're inside of that sphere that we saw in Blender, and then you shouldn't see any seams or anything like that because of the way we set up the camera and because the textures are set to clamp. And you'll notice that this shiny sphere that I made right here hasn't seemed to notice the skybox. And that's because we need to bake a reflection probe first. So to make one, you can go to right-click in the hierarchy, go to light, and then reflection probe. And then it's just going to pop up right there. And then it's going to disappear, but you can select it in the hierarchy to find it again. And let's just get that out of the way. So what we're going to do is we need to bake the reflection probe, and then that's actually going to create a cube map texture, and then it's going to send that cube map texture to any shiny objects around the probe, and they'll start using it as a reflection. But first, I'm going to go to lighting, click on this little arrow under generate lighting, and then clear baked data. And I'm going to do that because if there's any textures already in the spot where the reflection probe is going to save, then you might have some issues. So go over to the lighting tab and then clear baked data. So back to the inspector with the reflection probe selected, we can go to bake. And then there we have it. So now all these shiny objects are going to notice our skybox. And even the things that aren't shiny look a little bit more gold, and that's because they're also reflecting the skybox a little bit. All right, so there we go. So since we noticed that these shiny objects are using the skybox, that means the cube map texture has been saved somewhere. And to find out where it is, just go to your assets folder, your main folder, and then go to scenes, and then sample scenes. And this is where it's saved. And we don't want to just drag and drop this into the assets folder directly. We want to make a copy of it. So I'm going to double click, and that's going to open it in GIMP for me. You might need to right click and then open with. And then here is the GIMP texture. So what we can do is file and export as, and then let's just go to the main assets folder, and then I'll call this reflection probe gold.exr, and then export it there, and then you can just exit out of GIMP at this point. So here we are, and if we look in the assets folder, we have this new reflection probe gold texture, and right now it's 2D shape. So go ahead and set this to cube and then hit apply. And then this is now a cube map. But to actually use it, we need to make some shaders for our spiritual stone. Let me go ahead and drag that out and put it right here. You should have something looking like this. This is just a raw FBX. I haven't done anything to it. And now we're going to write some shaders so that we can actually use this cube map that we just made. I've gone ahead and created a new unlit shader and opened it up in VS Code. And to do that, you can right click in your assets and then hit create, and then shader, and then unlit shader. And then you can go ahead and open that in your code editor of choice. And then let's go ahead and right click that shader and then hit create and material. That'll create a new material based on the shader. And then let's go ahead and grab that, drag that onto the gold of the stone. And it should turn white. And if you've never worked in a shader before, this is going to look a little overwhelming, but let me explain briefly what each of these sections is for. So the Properties tab is where you can create variables that will show up in the Unity editor. So you can see right here we have this variable called main text, and texture is in quotes, and then it says 2D and then white. So what this is saying is create a new variable main text. It's going to hold a 2D image, and then if there's no 2D image, just return a white color, and that's why our stone looks white right now. And you can see in the Unity editor we have this little section called texture, and that's because we put texture in the string here. And since there's nothing in it, it's just returning white. And then down here, you'll see these tags and LOD, and this block, usually you're going to use it for turning things transparent, and we'll worry about that a bit later. And then you have this pass block, and then CG program means this is the start of some code that looks a lot like C++. And these right here are for referencing functions that Unity uses in almost every shader, and that's just so you don't have to define them every single time you make a new shader. And I'm going to go ahead and get rid of this one since we don't need fog. And if you look down here, we have something called struct appdata, and this is basically declaring a new kind of variable called appdata. And appdata is basically information passed into the shader about the object's position and how all its vertices relate to each other. And then we have another struct down here called v2f, and v2f is pretty similar to appdata, but it's going to be the final object that we return. So basically it decides what the object is actually going to look like. And I'm going to get rid of these because we don't need fog. And then right here is typically where you would declare those variables that we defined up here. So we have one called main text, and then so we declare main text as a sampler 2D, and really that just means 2D texture. And then you have a float for main text st. This isn't really important. It's mostly for if you need to tile a texture, which we don't need to do. So then down here you have this vert function, and it returns a v2f, and it takes in an appdata. So really the point of this function is to turn the appdata, which is kind of like the input data, into a v2f, which is what we're going to return at the end. So we define a new v2f. We tell it where all the vertices are. We tell it what the UVs are, which is if you're going to use a texture. And then we have this transfer fog thing that I'm going to get rid of again. And then at the end, we just return O, which is the v2f that we created. And then finally, at the end, you have this frag function, and it returns a fixed 4, which is another way of saying it returns a color. And it's 4 because it has RGB and alpha values. And it takes in the v2f. It's called I here, but that's the O that we made before. And then it outputs to svtarget, which is really just what the camera sees. So here we have something that's sampling the texture. So if we had passed in a texture right here, this is where it would find out what the texture looks like. And I'm going to delete that. And then here's some fog stuff that we don't need, so I'm going to go ahead and delete that. And then at the very end, this return call line. This is where the color that the camera sees is actually returned. So call is equal to main text, and there's nothing there, so it returns white. And then it returns call right here, so at the end it's really saying return white. So what if we want a different color? Well, what we can do is define another property up here. So I'm going to write underscore tint, and then I'm going to put in a string tint color, and then I'm just going to say color right here, and you'll see why. And then this is going to be 1111, and this is really saying the RGB values are all 1, which is white, and the alpha value is also 1. And then since we declared the property up here, we also need to declare it down here. So I'm going to write float 4 because it has 4 floats, and then I'm going to write tint. And I'm going to put a semicolon because this is like C code. And then to actually use that tint, well, first of all, let's Control S and then go back to Unity. And we can see that we have this new property called tint color, and it's white. So I can change this around to different colors like red. But nothing happens to our object, and that's because we haven't actually used the tint yet. So I'm going to return call times tint, and that's going to multiply these two colors together. So if we go back to our scene, we see that the object turns red. So I'm just gonna move this to a nicer gold color, maybe right there. And so now the stone looks gold. So we understand shaders a bit better now. Let's go ahead and write the code that'll allow us to use reflection maps. So if you think about it, in order to calculate the direction of a reflection, you need two things. One is the direction the ray of light from the camera is traveling when it hits the object, and two is the direction that the face of the object is facing. If you'd like, you can think about it as a ball bouncing off an object. You need to know the direction of the ball, and you also need to know the angle of the thing that the ball is hitting. So right here, let's write those two things out. So what we need is the direction of ray from camera, and we need direction of the face of the object. And to help us out here, I'm going to add a couple things to these structs. So I'm going to have a float3 called normal. And normal is kind of like a little arrow that points in the direction of the face. And Unity will just give it to us as long as we specify normal right here with this colon. And then I'm also going to create a float3, another vector, and that's going to be called reflection. And I'm going to add a colon, and then I'm going to write text chord 1. And that's pretty weird, but the reason for that is because Unity will pass stuff into shaders as text chords. So that's why you have text chord 1 and text chord 0 here. It's just saying, I want Unity to give me this thing. Okay, so let's come back down here. So the direction of a ray of light from the camera. Before we can get that, we need to know where the object is in relation to camera. So let's create another vector, just 3 coordinates in 3D space. So we'll write float3 and then world position. And this is equal to multiply, because it's a matrix multiplication, unity object to world. I'm going to hit tab. And then v.vertex. And then I'm going to write dot xyz just to get the xyz coordinates. This is going to look really weird if you've never dealt with this kind of stuff before. And if you want to know where I found these functions, I'll link the documentation in the description. So what we're doing is passing in the vertex of the object, all the vertices, and then we're finding out where that is in relation to the camera. That's what this multiplication is for. So now that we know where the position of the object is in relation to the camera, we can get the direction a ray of light from the camera would come. And I'm going to create another float3 because it's a vector in 3D space. And I'm going to call that world view, okay? And I'm going to write unity world space view direction. And then parentheses, and then I'm going to pass in that world position thing that we just made, okay? So this is going to give me a vector, which is just 3 coordinates that tells me what direction the ray of light from the camera to the object would be. And I'm also going to write normalize right here. And the reason I'm doing that, and then put some parentheses around this. Oops. And the reason I'm doing that is because we want this object to have a magnitude of 1. Basically, the length of the arrow corresponding to the ray of light will be 1. And we do that just because it's easier to work with vectors that are normalized. So that world view right there, that's the direction a ray of light from the camera would take. So we're done with that part. Let's work on the direction of the face of the object. And to get that, I'm going to write float3 world normal, and I'm going to set that equal to unity object to world normal, this one right here, okay? And then I'm going to pass in v.normal. So this v.normal, that's this thing that we just created right here. It's the same thing. So we're passing in the normal from Unity into this shader, and then we're saying what direction would that normal be from the perspective of the camera. So that's what this function is doing right here. And now that we have all those, we can actually get the reflection direction. So we have the direction of a ray of light from the camera, the direction the face of the object is facing, and now what I'm going to do is write O dot reflection. That's that thing that we made up here. And I'm going to set that equal to reflect. So this is another function. And I'm going to do negative world view, comma, world normal. And why did I put a negative sign right here? Honestly, I can tell you I have no idea. That's just what they do in the documentation. And at this point, I want to note, if you don't understand what these functions are doing or how all this works, that's not too big a deal. You can go to the documentation, you can read how they found these functions, and you can find out what the name of the function is. And if you want to, you can take the time to study how reflections work in 3D space, but for the purpose of this video, all you need to do is know that these are the names of the functions and these are how you use them. That's everything we need to do in the vert function, and we're almost done, but we need to tell the frag function that we're going to use a cube map instead of a straight up 2D texture. So to do that, I'm going to go to this line here, and right now it's sampling a text 2D, which just means 2D texture, and I can change that to text cube, like that. And then these UVs are what you would use if you were using a normal texture, but we're going to use that reflection that we just defined in the vert function, okay? And that's Control S. And now let's go back to Unity, and we get an error. And that's because we're using main text right here, and we defined main text as a 2D texture. So let me just double check what we need. So we need to define it as a cube right up here. So let's go ahead and change 2D to cube, like that. And then I think we might also need to change it down here from the sampler 2D. Let's see. So yeah, we're gonna do sampler cube main text. And I'm gonna go ahead and get rid of this because we're not gonna use it. So sampler cube. I think that's correct. And let's go back to Unity, see if we get any errors. And undeclared identifier main text. And that is because we still have main text right here, so we don't need UVs, so I'm also going to get rid of this line. Let's see. And no errors. Okay. So now we're back in Unity, and let's look at the material that we made from this shader. So right now there's nothing in it, and all it's doing is returning our tint color. So let's go ahead and grab our reflection cube map right here, and then drop it into this cube map slot. And then suddenly our stone is using that texture, so we can check if it's working by rotating it around. And you can see that it's giving us that kind of N64 texture look. The color is a bit off though, so I'm going to go to tint color and make it, let's keep it up at the top and then maybe drag it towards more of a yellowish kind of thing. I think that looks pretty good. So that is the gold reflection, and it looks pretty bad, I'll be honest, but it looks a lot like the N64 reflection, so I'm going to keep it like that. Alright, so that was the gold reflection. Let's work on the emerald one now. So navigate to whatever folder you stored all those textures in, and let's select all of them. And we're going to do high quality, 128, and no filter, and clamp. We're going to apply. And then let's create the skybox material. So go to create and material. And I'll just call this emerald box. And we want this shader to be a skybox shader. So go to the selection and then skybox 6-sided. And we're just going to drag and drop all these textures into the corresponding slots. So down is going to go in down, -x to -x, and -z, -z, +x, +z, and up. All right, and nothing's happened yet, and that's because we haven't selected it. So go to the lighting tab, environment, and then just drag and drop. And there we go. It looks absolutely terrible. So this shiny ball right here, you'll notice, is still reflecting the old skybox. So what we're going to do is clear bake data. That'll just get rid of the old reflection maps. You'll notice everything turns dark. And then go to your inspector, reflection probe, and then bake. And there we go. Now this skybox has been put into a cube map. So let's go ahead and try to access that. So go to your main assets folder and then go into scenes, sample scenes, and there they are. Honestly, I don't know if there's a difference between these two. I'm just going to take the second one. So I'm going to open it in GIMP. There we go. And here it is. So go ahead, go to File, Export As, and then go to, I'll just go to the main assets folder, and then I'll call it Reflection Probe Emerald.exr and export. Exit GIMP, and back in our scene, you can see that now we have this emerald reflection probe. And just to clean things up, I'm going to go ahead and get rid of all of these sides to the cube map. I'm just going to delete them because I have them saved somewhere else, but make sure you have them saved somewhere in case you ever want to go back and make the cube map again. There we go. And this reflection probe is saved as a 2D texture. We want to make sure that Unity recognizes that it's a cube map, so change this to cube. And then bilinear, normal quality, that looks good. Just apply all those. And then now we need to make the emerald shader that's going to use this cube map. And before we do that, I'm just going to set the skybox back to the original so that we don't have to look at that anymore. And there we go. We can also rebake the reflection probe if you want to get that back to normal. So clear bake data and reflection probe and bake. And there we go, back to normal. Let's now right click in the assets folder and create the emerald shader. So shader unlit, we'll call it emerald shader. And let's go ahead and open that up. And I've still got my gold shader open here. And what I'm going to do is copy from this curly brace all the way down. Control C. And then just replace everything in here with that. And make sure you leave the name untouched. There we go, Control S, and then back to Unity. And let's go ahead and make a material with this shader. So create material. Okay, and then put it on the emerald. And there's no texture, so it looks weird. And what we can do is just go ahead and pop this reflection map into the cube map. And there we go. So you'll notice that the original emerald is see-through, transparent, and this one is not. So let's try and fix that. So I'm going to go to the code. And I talk about transparency in my last video, the antechamber video. So I'm going to go a little bit more quickly here, but just follow along and then you'll have a transparent emerald at the end. So first, I'm going to change this opaque to transparent. And that doesn't do much. It's just a tag that helps Unity organize the shader. But next, what we can do is Q equal transparent. And this line is to make the transparent object render after the opaque objects. And that's because we want them to be rendered first so that when the transparent object is rendered, it knows what's behind it. And that'll help it display those objects. And then what we're going to do is blend source alpha 1 minus source alpha. And this line is actually where the transparency happens. You can think of it as a sentence that says, I want to blend this object with the objects behind it. And this object's contribution to the blending is its source alpha, which right now is 1, so 100%. And the contributions of the objects behind it is 1 minus the source alpha. So 1 minus 1, which is 0%. So as we increase, or as we decrease the source alpha, then this object will be contributing less to what we see, and the objects behind it will be contributing more to what we see. And lastly, we're going to write z right off. And this has to do with something called the depth buffer. Essentially, it just makes sure that if there's any objects that are behind the emerald, they're still going to be rendered, which obviously is what we want because if something's transparent, we want to see what's behind it. And down here, right now, this call is what is holding the alpha value. And right now, the alpha value should just be set to 1 because there's no transparency in that texture that we put in main text. So what I'm going to do here is write fixed for, because that's what needs to be returned. And I'm gonna write call.rgb, which is just the RGB values from the texture. And I'm gonna write 0.5. So this is the 4th spot in the fixed for, and it decides the alpha value. So right now I'm saying the alpha value is 50%. So if I save and then go back to Unity, we can see that we have some transparency going on in the emerald. It's not quite what we're looking for though, because if you look at the original Ocarina of Time stone, it seems like the black parts in the texture are see-through, but the green parts are not see-through. So to fix that, what I can do is say the alpha value is just the green value in the texture. And that's a little bit weird to wrap your head around, but you can think of it as bright spots will be less transparent and dark spots will be more transparent. So back to Unity, and that clearly affected the alpha a lot, and that's because there's a lot of dark spots. So we obviously don't want this because you really can't see anything there at all. So if I go back to the code, what we can do is say, I want the tint to add to the texture instead of multiply the texture. So you can try to think to yourself why that might be if you think about it in terms of RGB values. But if you're adding something to RGB, it's going to naturally make it brighter than if you're multiplying to RGB. So if I go back to the scene, you can see our tint right now is totally white. So I'm just adding white to anything and it's going to make it white. So let's make it green, and then let's make it a little bit darker. And then you can see that's having some kind of an effect. So let's do maybe like right there. And it's still not quite where we want it. So let's see, what can we do? Oh yeah, I know what's going on. So the alpha for this is set to 100%. So it's just overriding everything. So let's decrease that a little bit. And now we see that's looking a little bit better. So let's try and play with those values, see if we can get something good. Let's see. Yeah, I think that looks okay. It's kind of like the original stone. And then, all right, so I played with the values a little bit and I ended up with this. I think that looks pretty good. And let's go to our texture. And I think part of the problem is the resolution is a bit too high. So let's see if we can change some things around. I'm gonna change the max size to 32. And that looks a little bit better, maybe 64. Magic number, and that looks pretty good. All right, so I cheated a bit and I used a reflection map that started with a bit of a lower resolution in GIMP. So I'll be sure to leave an annotation in the video, and that's why this looks totally different. So I'll also include that texture if you want to try it out and have a better looking stone. But honestly, I feel like this looks pretty good. So if you made it to this point in the video, I hope you're satisfied with the results, and I also hope you'll stick around for my next video.